Hello, everyone. So this week we're going to continue studying Chapter 6, Geometry and Trigonometry. So the first thing that we have to understand is the three-dimensional plane. And here we can see an image that shows us precisely a three-dimensional plane. So we have an x-axis, which is the one we see here. We have a y-axis, which you can see here. And you have a z-axis, which is the third dimension. So how do coordinates work here? Well, they work in the same way as they would in the two-dimensional Cartesian plane. So to find point P, for example, first we travel the distance x, which is this one. Then we move in the y direction. And finally, we would go up z units to finally arrive to point P, which would be described with x, y, z. So here we are with an actual picture of a point in a three-dimensional plane. In this case, this point is 3, 4, 5, as you can see there. So that means that 3 units in the x direction, then 4 units in the y direction, and finally 5 units up in the z direction. And we arrive to point 3, 4, 5. So here are a couple of formulas that we're going to be applying to this three-dimensional geometry. For example, the distance formula. So the distance between 2 points x1, y1, z1 and x2, y2, z2 is, and notice that this distance formula is exactly the same one that we would use for the two-dimensional plane. So it's the difference in x squared plus a difference in y squared plus a difference in z squared and square root of all that. Likewise, for the midpoint, we have the same formula that we would use as well in the two-dimensional plane. Notice that we're adding the x units and dividing by 2. And that would be the x coordinate of the midpoint. Adding the y coordinates and dividing them by 2 would give us the y coordinate of the midpoint. And likewise, with the z coordinates, adding them and dividing them by 2 would give us then the coordinate z of the midpoint. Very well, so here we are with example 6.1, where they ask us to use the distance formula to show that 3 points F, G, and H are collinear points. So what are 3 points that are collinear? Collinear means that they have to be on the same line. So if I have point F, and this is point G, and this is point H, if they are collinear, it means that they lay on the same straight line. In order to prove this, if 3 points are collinear, that means that if I find this distance and add it to this distance, right? If I find FG and add it to GH, it should equal the full distance from F to H. Now that is logical. Just imagine if they were not collinear. If they were not collinear, then let's say this is point F, this is point G, and this is point H. Then we would have a situation where the points are not collinear. They would form a triangle. Then obviously this distance plus this distance would be more than FH. Okay, so let's start by finding the distance between FG. So FG would equal the square root. It would be then equal to 1 minus 2 squared. Those are the x coordinates, plus -1 minus 4, so -1 plus 4, and this squared, plus 3 minus 5 squared. So you have to do it in the same order. Doesn't matter if you do it backwards, but then you would have to do them all backwards. Okay, so if we do the math here, this is going to give us square root of 14. Now, let's find GH. GH. So for GH, we would have square root, and let's say for G, 2 minus 5 squared, that would be the x coordinates, plus negative 4 minus minus, so negative 4 plus 13 squared, plus 5 minus 11 squared. And if we do the math here, this is equal to 3 square root of 14. And then finally, we have to find FH. So let's do FH, and FH would equal then the square root of difference in the x coordinates, so 1 minus 5 squared plus negative 1 minus minus, so negative 1 plus 13 squared plus 3 minus 11 squared. And if we do the math here, this is going to give us 4 square root of 14. And this is already proving that they are collinear, because notice that if we add these two, adding these two would equal 4 square root of 14. Therefore, points F, G, and H are collinear. Okay, so now we're on example 6.2, and they tell us that given 3 of the vertices of a parallelogram ABCD, and they give us the coordinates ABC, and they ask us to determine the coordinates of vertex D. Okay, so before we do this, we have to understand a couple of things about parallelograms. The first thing is that it's standard practice to label the vertices in alphabetical order, whether it's clockwise or anti-clockwise. So notice that here we have A, B, C, and this is D, which we have to find. Now, because it's a parallelogram, this side and this side are equal and parallel, and the same thing for this side and this side being equal and parallel. Now, the interesting thing is that if you draw these diagonals, the diagonals are going to meet exactly at the midpoint. So M is the midpoint between A and C and D and B. So we're going to use this fact to find the coordinates of vertex D. So first of all, let's find the midpoint. So the midpoint would be between A and C. That means that the coordinates of the midpoint should equal the sum of, say, we're doing A and C, so this would be 3 minus 1 over 2. That would be the x coordinate. The y coordinate would be minus 1 plus 1 over 2. And the z coordinate should be 2 plus 2 over 2. That means that M, the midpoint, would be then 1, 0, 2. Okay, so now let's find D. Because we have the midpoint, let's just call D X, Y, and Z. So we know that X plus the B coordinates, right? So X plus 1 divided by 2 should equal 1, because that would give us the X coordinate of D. Then we know that Y plus 2 divided by 2 should equal 0. And finally, we know that Z minus 4 divided by 2 should equal 2. So solving for X, Y, and Z, we have that coordinate D, or the coordinates of vertex D, I should say, would be then 1, right? Because 1 plus 1 is 2, and 2 divided by 2 is 1. Negative 2, because negative 2 plus 2 is 0, divided by 2 is 0. And then finally, Z would have to be 8, because 8 minus 4 is 4, and 4 divided by 2 is 2. So this would be the answer. These would be the coordinates of vertex D. Okay, so here we are on the next slide, and the next slide is about 3D solid shapes. Now, in the IB exam, they expect you to be able to find volumes and also the surface area of these different 3D solid shapes, like the sphere, the cylinder, the cone, the cube, the cuboid, the hexagonal prism, the square base pyramid, the tetrahedron or triangular base pyramid, and the triangular prism. So in the next slide, we also see different names for parts of the cone and the pyramid. So notice that this is the vertex of the cone right here, a vertex. The height of the cone, now all the cones that we study are going to be actually right cones. So that means that you can form a right triangle using the height and the radius as well as the slant height. The slant height is this here. You need to know the slant height in order to find something like the surface area, for example. But then we have the features of a pyramid. So the pyramid also has a height. Now the interesting thing about this pyramid, this is the square base pyramid, is that the height goes right to the center of that base. And you also have a right triangle pattern here as well, right? With the height, with this distance, and with the slanted height, or the height of a triangular face. Very well. So in the next slide, we actually have an exercise or an example. And it's example 6.3. And it says that a triangular pyramid sits on top of a triangular right prism. The prism has a height h. Find the height of the pyramid in terms of h so that the prism and the pyramid have the same volume. So in this question, they're basically asking us to compare the formulas for the volume of a pyramid, a triangular base pyramid, and of a triangular right prism. So for a prism, we have that the volume of a prism is equal to the area of the base, which is a triangle, times the height. Whereas for a pyramid, you have a very similar formula. The volume of a pyramid is one third the area of the base times the height. So the difference here is this 1/3, as you can see. What that means is that in order for these two volumes to be equal, you will need to have the pyramid with a height that is 3 times the height of the prism. So then we should write a 3 here, and then we could make these equal. So that would be the answer. It means that you would have to have a height of 3h for the pyramid in order for the volumes to be equal. Very well, so here we are now in example 6.4, where they ask us to compare a sphere and a cone. The radius of the sphere and the radius of the cone are both r. The height of the cone is 2r. Find the exact value of each ratio. So we're going to start with part A, where they want us to find the ratio of the volume of the sphere to the volume of the cone. So let's recall that the volume of a sphere is equal to 4/3 pi r cubed. And we have that the volume of a cone, is equal to 1/3 pi r squared times the height. But they already told us that the height of the cone is 2r. So we can substitute h here for 2r. So let's do that. And if we have 2r, then we can rewrite this expression as 2/3 pi r cubed. So since they want us to find the ratio of the volume of the sphere to the volume of the cone, then what we have to do is divide. So 4/3 pi r cubed divided by 2/3 pi r cubed and this obviously will give us 2. So that means that the ratio of the volume of the sphere to the volume of the cone is 2 to 1. Okay, so I'm going to erase this, and we're going to do part B. Okay, so now let's do part B. So for part B, they want us to compare the ratio, or they want us to find the ratio of the surface area of the cone to the surface area of the sphere. So let's start with the surface area of a cone. So the surface area of a cone is equal to pi r squared. That's the surface area of the base, which is a circle. Pi r squared plus pi r times L. Now L is the slanted height. But notice that because this is the height here, and the base of this right triangle is R, we have that L, the slanted height, is actually equal to the square root of h squared plus r squared, which is the Pythagorean theorem. So let's substitute that there for a second. And let's rewrite it as square root of r squared plus h squared. But again, h is equal to 2r. So I can substitute h for 2r, and that would then be 2r squared. But this expression here can be simplified because this would be then the square root of r squared plus 4r squared, and this equals square root of 5r squared, and we can simplify that as r square root of 5. So notice then that in reality, I can rewrite this thing as, and I'll do it here, I can rewrite it as r squared square root of 5. So the reason I'm doing this is because I want, of course, a simpler expression in terms of r only. All right, so now we want the surface area of the sphere. And that one's easy because it's simply 4 circles, 4 pi r squared. Now, let's find the ratio then between the surface area of the cone to the surface area of the sphere. That means that we have to divide this surface area by this surface area. We can do a little more simplification here. Notice that we have a common factor, which is pi r squared. And that times 1 plus square root of 5. So let's rewrite it as that. So then the ratio would be surface area of the cone over surface area of the sphere. And that is going to be pi r squared times 1 plus the square root of 5, and all of this over 4 pi r squared. So notice that this cancels out, and I'm left with 1 plus square root of 5 over 4 as the ratio of the surface area of the cone to the surface area of the sphere. Very well. So you will notice that the following slide is actually exercises 6.1, where you have a series of questions that you will need to answer. And if you have any questions, I will be sending a video on Wednesday. So once you're done doing those exercises, you should go on or move on to the next subject, which is angles of depression and elevation. So in this first picture here to the left, we see a man standing, and this is his line of sight. He's looking at the top of the tree. Now this here would be a horizontal, and this is the angle of elevation. Now, because we have a right triangle, then obviously we can use the Pythagorean theorem to solve problems with these cases. Now, on the picture to the right, you see a different situation where there is a person standing on a cliff, and this person is looking down to a ship. So if you grab the horizontal, this is what's called the angle of depression. Now, there's something that I'm not mentioning here, but is very important. The angle of depression is actually equal to this angle here, the angle of elevation to the ship. And this makes things easier when solving the problems, mainly from a perspective point of view, because then you would have that this right triangle here is equal to this other right triangle there. So moving on to the next slide, we have example 6.6, where they say that a man who is 183 centimeters tall casts a shadow 72 centimeters long on horizontal ground. What is the angle of elevation of the sun to the nearest tenth of a degree? So we have that they want us to find this angle here. Now remember that this is a right triangle, so we can just use a trigonometric ratio. In this case, we have that these are the legs of the right triangle, and this would be the hypotenuse. Then we can use opposite over adjacent, which is tangent, right? So we have that theta is equal to the inverse tangent of opposite, 183, over the adjacent, 72. And if you plug this into the calculator, it's going to give you approximately 68.5 degrees, rounded to 3 significant figures. Very well, so now we're in example 6.7. And it says that during a training exercise, an Air Force pilot is flying his jet at a constant altitude of 1,200 meters. We can see that here. This is 1,200 meters. His task is to fire a missile at a target on the ground. At the moment he fires his missile, he is able to see the target at an angle of depression of 18.5 degrees. So this is the angle of depression here. If the missile travels in a straight line, what distance will the missile cover to the nearest meter from the jet to the target? Okay, so to make things easier, remember that this angle is equal to this one over here, right? So this is 18.5 degrees. And we obviously have a right triangle. So all we need to do is decide which trigonometric ratio we can use to find x, which is the distance between the jet and the target. So we know that we have to use the sine function, because sine of 18.5 degrees is equal to 1,200 divided by x. That means that x has to equal 1,200 divided by sine of 18.5 degrees. And plugging that into the calculator, it's going to give us approximately 3,781.85. But they want us to round, they said, to the nearest meter. Okay, so we have to rewrite this as 3,782 meters, and that would be the answer. Okay, everybody, so now we're in example 6.8. And it reads that a boat is sailing directly towards a cliff. The angle of elevation of a point on the top of a cliff and a straight ahead of the boat increases from 10 degrees to 15 degrees. So at first the angle of elevation here was 10 degrees, and then it got a little closer and it was 15 degrees. As the ship sails a distance of 50 meters, so there was 50 meters between here and here. And then they say find the height of the cliff. So they want us to find the height of the cliff. So notice that we have two triangles here. This is one triangle, one right triangle. Would be this one with a 15-degree angle of elevation. But we would also have one with a 10-degree angle of elevation. And everything should be in terms of h and x. So what we're going to do is that we're going to go to the next slide where I have separated those two triangles in order to solve this problem. So let's erase this and let's move on to the next slide. So here we are on the next slide, and we've separated the triangles, as you can see. So for this first one, we know that tangent of 15 is equal to h over x. Therefore, the height, which is what they want us to find, is equal to x times tangent of 15. All right, so for the next triangle, we have that tangent of 10 degrees is equal to h over x plus 50. Therefore, h is equal to x plus 50 times tangent of 10 degrees. Okay. Notice that this has two variables, so we're going to have to solve for x first. We do know as a fact that x tangent of 15 must equal x plus 50 times tangent of 10. That's because these two also equal h, so they have to be equal. So let's solve for x. So notice then that we can rewrite this as x tangent of 15 is equal to x tangent of 10 plus 50 tangent of 10. Then we can move this to the other side, and we can factor out x. So we're going to get x times tangent of 15 minus tangent of 10 is equal to 50 tangent of 10. Now notice that I'm not calculating 50 times tangent of 10. I'm doing that till the end. That's what I suggest you guys should do as well. So then we have that x is equal to 50 tangent of 10 divided by tangent of 15 minus tangent of 10. So this is x, and I'm going to leave it like that. I won't change it until the end when I want to round. So going back, we see that h is simply x times tangent of 15. So that means that h, which is equal to x times tangent of 15, would be the same as saying that h is equal to 50 tangent of 10 divided by tangent of 15 minus tangent of 10 times tangent of 15. Now we finally plug this into the calculator, and it's going to give us approximately 25.783. But we have to round it to three significant figures. So we have that the height is approximately 25.8 meters. Very well, so here we are on example 6.9, which is going to be the last example that I solve on this video. So it says, using a suitable right-angled triangle, find the exact minimum distance from the point 8.3, this one here, to the line with the equation 2x minus y plus 2 equals 0. So this linear equation here, this line. Okay, so notice that if you want to draw the smallest distance, it would be a perpendicular line, as you can see here. That's why you have that perpendicular line. Therefore, you have a right angle here, and then we're using a right triangle for this as well. And they want us to use this to find d. Now, there's several approaches you can use, but the one I'm going to use here is by equating two different ways of finding the area. So notice that we can find the area of this triangle very easily by just using the fact that this distance here, the base here, is the difference in x. So that means that this base is going to be the absolute value of 8 minus 1/2. And that equals 15 halves. So the base is 15 halves. Now for the height, all we need is the absolute value of the difference in y. In this case, it's 18 minus 3, therefore 15. So the area, the total area of the triangle in the figure is going to be 1/2 times the base, 15 halves, times the height, which is 15. And this equals 225 fourths. Okay, so now we have to compare this area to another way of finding it. What's the other way of finding it? Well, if you look at this here, the hypotenuse is actually also a base, and d would be the height of the same triangle. So first we need to find that hypotenuse. The hypotenuse is simply going to be the square root of difference in x squared, so that means 15 halves squared, plus the difference in y squared, which is just 15 squared. And if you plug this in the calculator, it's going to give you 15 square root of 5 halves. Okay, so we're almost ready to solve. Because the areas are the same, it means that 1/2 times the base, in this case we're using the hypotenuse, so 15 square root of 5 halves times the height d must equal 225 fourths. So now we have a simple equation, and all we have to do is solve for d. So if you solve for d, you should get that it equals 3 square root of 5. Then the answer would be that the minimum distance, we don't have any meters or centimeters here, so we'd have to say that the minimum distance from point 8.3 to the line would then be 3 square root of 5 units. And now the reason we leave it in terms of the square root of 5 is because they're asking for the exact minimum, as you can see there. Okay, so that would be it for this video. Notice that after this slide, you have the following exercises, which are exercises 6.2. So please do all those as well. And again, if you're going to have any questions, I'm going to collect the questions, put them in another video that I'll be sending out on Wednesday.